So let's shift gears and let's talk inequality for a few minutes. And what I want to do so that we can, well, let me wait, hang on. So as we talk inequality, there's a reason I have the inequality section directly following the labor union section. And the Robert Reich video, Inequality for All, which is in one of the modules, or in the module, I think helps connect those very well. In fact, as I mentioned a few minutes ago, I thought about having the Reich video as part of the labor union section, but decided not to, just because I preferred it in the inequality. And maybe just because of the title, if nothing else. But here we have a scenario that's developed in our country where, in the face of weakening labor unions, expanding globalization, where I don't need to have products manufactured here in the U.S. any longer in order to assure good quality and assure short time frames. It's become so inexpensive to transport something from Asia to Chicago, whereas 40 years ago it was very expensive, right? Today, transport costs are a rounding error in most manufacturing budgets. And that's probably an overstatement, but they're not significant, because on a per unit basis it costs very little to bring that toy, boxed, packaged, perfect, shiny and new, from where it was made in Shenzhen and have it delivered in your home in Sandy, Utah. Very little. So all of these things, supply chain management, etc., has made it really hard for U.S. workers to lower skilled production workers to maintain the kind of wage structure that they had, right? And unions are fighting hard for that, but it's a fight that is hard to win because we like going to Walmart and Costco and pay low prices for our goods. Well, that leads into this whole concept of inequality, because the working families in this country, the blue-collar families, don't have the kind of wage capacity that they had for decades and decades. And so we've got this rising level of inequality. I think I do a fairly good job in the videos of talking about some of the historical effectiveness, looking at wages and industrial revolution and technological advancement. I don't want to spend any real time there unless you ask me to, but I do think it's probably worth looking at how we model inequality with a Lorenz curve and with a Gini coefficient. Okay, so we'll spend at least a few minutes doing that, and I'll walk you through some mathematic shortcuts, if not tricks. They're not tricks, they're shortcuts. But let's talk a little further about why inequality is expected and why it's problematic. In a capitalist society, where we know some people own production and some people are producer workers, right? I mean, that's just part of the structure of a capitalist society. And for good or ill, in the Western world, which is increasingly more and more of the globe, capitalism is the system that reigns. For some period of time, some decades, socialism seemed to be a potentially credible system. We now have virtually, literally no examples of large socialist systems that have done anything but become destructive. So that chapter is pretty much closed at the moment. Interestingly enough, locally, the dominant church, the LDS church, who is thought of as being very conservative, has had some of the more recent experiments with socialism within what I think some of the church members refer to as the United Order, and enclaves of people, which now 150 or so years ago, trying to live what really are communal lives, and realizing that humans tend to be problematic inputs to that, because we tend to be selfish and we want more for ourselves. But even those experiments didn't work. So capitalism is the name of the game the world over now. Even China is become a capitalist nation. How many of you know Ming-Chi Lee at the U, one of the economics professors? Have you ever had a class from Ming-Chi?
No, I just I was introduced to her by another professor.
Well, and this is not the female Professor Lee.
Oh.
There's a male Professor Lee.
That's someone
Yeah.
else.
And he is, I'll bet you she's 50 years old now, give or take. First class intellect, and an outspoken opponent of the Chinese government from which he was exiled. In fact, if you look at some of the photographs of the Tiananmen Square uprising in the 1980s, I think it was, maybe it was early 1990s, there are some photographs in which he is present because he was one of the leaders of that rebellion, and he was a critic of the movement towards capitalism at the time, and now he is a critic of the Chinese government because they become too capitalistic. And so he's kind of moving sides, if you will. But for him, there's a storyline that's consistent here. Fascinating intellect, and as it turns out, a really nice guy. If you ever have a chance to take a class from him, I have a lot of respect for him. But we've had some of the more heated debates that I had while I was in my doctoral program, nearly shouting each other out of a room one time. Regardless, inequality in a capitalist system is expected. Inequality in a system that rewards experience and tenure has to be expected. Inequality in a system in which young people aren't endowed with a net worth immediately is expected. So you either have or you will watch a video. There really is, it's not a video with live actors, but it's a voiceover and somebody's looking at some graphic representations of what he talks about as inequality of wealth, and talks about as inequality of income, using the terms interchangeably. And it's hard to know what he's discussing because he flips back and forth, and because of that, some of what he shows he doesn't show well. Okay? Think about this. If I'm 18 years old and I get my first credit card, and I use it like an 18-year-old would, right? Is it likely that I have a negative net worth? It's likely, right? Because an 18-year-old probably has limited savings or accumulated resources otherwise, maybe the blue jeans and tennis shoes they're wearing, right? But that's about it. And a credit card in their hands, they probably have a negative net worth at that point. Put them into college, and student loans being what they are, maybe having purchased an automobile, probably have got a loan for it, and now the vast majority of 18, 20, 22-year-olds, etc., probably have negative net worth. I think if you were to measure that in our country, that would be true. Now, they have an income, right? But net worth, wealth, and income are separate. Well, certainly income leads to wealth if there's surplus income that can be accumulated. But wealth and income are separate issues. And we have both a wealth inequality and an income inequality in this country, and some of it is just to be expected. If I am 70 years old, and I've had a lifetime of earnings, and I have my retirement account, and my home is paid for, and I've got some other savings, which is probable. I don't know how much my savings are. I don't know how big my retirement account is across the country, but I probably have something. Then the expectation is I have a grossly positive net worth, right? Well, just because of our age differentiation, some part of our economy is going to have very little wealth, and some part is going to have a lot more wealth, even if all the other influences are equal. It's just our system. And if you're accumulating and I'm working for you and spending everything, and you have a profit you're gathering because you own the company I work for, you probably are accumulating faster than I am as an individual, and that's just kind of the way it is. Some inequality is expected, and in a capitalist system, productive. Because if we didn't have some of us accumulating and some of us being willing to work so that we could support our lifestyle needs, then we wouldn't have economic productivity. So it is an expected condition. That it changes at times based upon a worker versus producer power relationship, or worker versus owner power relationship, or worker versus wealthy power relationship, is a function of other societal trends, policy trends, political trends, right? Maybe other conditions. We had a condition not too long ago, the Great Recession, which wiped out the net worth of lots and lots of people at the upper end of the wealth and income spectrum and at the lower end of the wealth and income spectrum. We had a similar effect when the dot-com bubble burst, if you will, right? We had a similar effect, much more dramatic in the Depression. And we've had a couple of recessions between these things, right? They have kind of caused some of this to ebb and flow. A good economic crisis is a great equalizer, and we become more and more equal. In the video, I think I give you some graphics that kind of show the ebbing and flowing of equality and inequality. They're probably worth paying attention to. We don't quantify them, I don't give you calculations for them, but I show you some graphic images with respect to them. So as you see that little video where the guy's talking about wealth inequality, income inequality, using some terms, you got to think about, and I would like you to think critically as to what he's really saying, because some of what he says gets kind of muffled in his flipping back and forth from position to position. But within all of this, we can agree, no, I'd like us to agree, that some level of inequality in a population is natural, normal, and probably economically productive. If we have a scenario where we have the percent of household income on one axis and the percentage of households on another axis, and this is X and Y, it's just that we've telegraphed Y to the other side of the structure here, okay? So this is still positive space. We've just telegraphed where you normally see Y here, and it's over here, but it's still Y, okay? If we have this, and we have a line that connects 0 and 100 here, that line we could say is the line of equality. So if we have, say, 20, well, that's not going to look really good, but hopefully it'll be my point. If we have a point on this line at 20% of our income and 20% of our households, we would be on the line of equality. And similarly, 40% and 40, and 60% and 60, and 80% and 80. So if 20% of the households have 20% of the income, 40% of the households have 40% of the income, and so on, then our line is the line of equality. Well, we would think of this as being probably a pure utopian, maybe socialist economy, and we don't have any examples of sustainability for that kind of economy, like it or not. But it is an ideal that might be considered, or at least something measured against. Okay? If we have a scenario in which the bottom 20% of the households have, let's say, 10% of the income, and then the next 20% of the households, let's say they have a combined 22% of the income. So here we have 10, and the next we have 22 combined. So we're here. And then 60% of the households maybe have, let me give that, maybe 60% of the households have 36% of the income. So that means the bottom 20% had 10, the next 20% have 12, if the 40% combined have 22, right? And the next 20% have 14. Let's say that this 20% going from 60 to 80 has then 16%, such that we are now up here at, let's say it's 52. And the remaining 20% then has, what's that look like, 48% of the income in the economy. Well, we clearly have something that's unequal, right? And we have these points that, when connected, form a curve. And that curve is the Lorenz curve. It's a curve. A couple of things you can count on for the Lorenz curve. It is on the line of equality or beneath it. It cannot be above the line of equality. And if you see it, if you have an opportunity to replicate a Lorenz curve for me on an exam, and if your Lorenz curve migrates above the line of equality, it will be costly for you. Okay? So, a word of warning. For it to be above the line of equality, it would be suggestive that the bottom 20% of the households have more than 20% of the income, in which case they can't be the bottom 20% of the households. It just doesn't work. All right? Well, how do we think about this? Let's suppose for a moment that we have 5 households, and we are then able to separate our households into quintiles or 5 equal parts. Or you could have 10 households and separate them into 5 equal parts, even still 2 households per separation. Or you could have 105 million households separated into 5 equal parts as well. But we'll just use the simplest. We'll say it's 5. And so we're gonna say here we've got Lindy, and nothing about what I'm about to represent income-wise is intended to be offensive, and if you're offended, I'm very sorry. Just tell me and I'll change the name. And we have Bailey, and Milo, and we have Nate, and we have Catherine. C or K, Catherine?
C.
Thank you. Catherine? Okay. And as expected, Lindy earns 100. Bailey, bummer for Bailey, earns 10. We've got our buddy Milo here. One of the names, and I'll let you guys decide which one it is as I tell you the income, earns 30. And then Catherine, well, Catherine happens to be queen. And Catherine earns 160. Well, in this, I don't have these ordered in any rank at all, right? So in order to construct a Lorenz curve, since I'm talking about quintiles or 20% groupings of households, I have to have the bottom 20% separate from the next and the top 20%. So if I have these incomes in this economy, society, I have to reorder them. And it doesn't matter whether I go smallest to highest or highest to smallest. I like to go smallest to highest. Okay. So in this case, I think it would be, and we're forgetting now the names, but we're putting 10 and 30 and 50 and 100 and 160 if we have them in ranked order. And these would be household incomes. And as it turns out, this is the bottom 20%, this is the next 20%, the next, and the next, such that I end up at 100%, and I've got 40, 90, 190, 290, 350 in total income. Right? I want to know what percent this income is of this total. So I'm going to say percent of household income. Now, this is the total. And I would like somebody, who's got a calculator handy that can, I think,
Yeah.
you're the man? Okay. So what is 10 divided by 350? I want to find out what percentage this is of the total.
10 divided by 350?
Yep.
0.028571.
I'm just going to call it 029. And 30 divided by 350 is?
0.08571.
0.086. 50 divided by 350 should be 17.
0.1428.
100 divided by 350.
0.2857.
And 160 divided by 350.
0.4571.
So these are the percentages of this total income that each quintile holds. Okay? It's going to become important to us in a moment. And now I want to have the cumulative income. So household income cumulative, such that I have 10 and 40 and 90 and 190 and 350. Right? So I just add them up, but this is the cumulative. So here, what I really should have said was these are the 20s. But this now would be the bottom 20% have 10, the bottom 40% have 40, the bottom 60% have 90, the bottom 80% have 190, the total 100% have 350. Okay? And these two numbers should be the same. So now we need to know what these percentages are as well. So percent of household income. And I know this one's going to be 100%. I know that this one's going to be 2.9%, just because it had nothing to accumulate, right? And this one represents all of them. And so, Nate, can you give me 40 divided by 350, please?
Yeah. 40 divided by 350 is 0.1142.
11.42%. 90 divided by 350?
0.2571.
And then 190 divided by 350.
0.5428.
So this doesn't surprise us, because if you take 2.9% plus 8.6%, given the right roundings, it'll equal 11.42. Add to it 14.3, it'll equal 25.71, and so on until we get to this cumulative 100%. I set it up like this because it helps us quantify what's happening over here so that we can form our Lorenz curve. But I want to, before actually doing the whole formation, I want to point something out about the Lorenz curve that's going to become important to us as we start to calculate the Gini coefficient. Okay? The Gini coefficient, which stems from the Lorenz curve, is simply a singular number that we can develop to help us understand where the Lorenz curve sits compared to the line of equality. Obviously, the more unequal the distribution of income is in a household, or the distribution of income is in an area, the further the Lorenz curve is from the line of equality. We could have a Lorenz curve directly on the line of equality, and that would be our perfectly equal socialist, utopian, what have you economy. Or, I guess it's possible in this case to have, with our 5 simple households, we could have a Lorenz curve that is literally right on the x-axis all the way over here to 80% and have it spike all the way to 100. That would be an environment in which Queen Catherine had all the income and we as her serfs had none. Right? We've seen those kinds of societies before. I think you have to agree that it's not possible for a Lorenz curve to be on the x and the y-axis expressly, because that would mean that all of the people have no income and no one has all the income. So that doesn't make quantitative sense. But that's if you had this broken out so that every household was represented by a tick mark. When we generalize, we can kind of see them on or very close to the this line, but that would be a monarchy that was very, very feudal, very unequal. But in this case, I want to be able to plot the Lorenz curve. Well, I can plot my Lorenz curve. I know that my bottom 20% of the households have 2.9% of the income. I know that the next grouping has 8.6%, such that the bottom 40% has 11.42 total. Okay? And so I'm using these numbers that we developed in our table to inform the lengths, or heights rather, of these spaces that we're putting together. And I know that the next one has 14.3% for a total for that 60th of 25.71. And the next one has then 28.6 for a total of 54.28. And the next one would be 100, right? But we don't have it. We have this other section, which is going to be the difference between the 48 or 54.28 and 100, which is 45.7. So here we have 45.7. Well, if we would like to know how to measure the area of each of those spaces, this becomes fairly simple for us. This is simply a right angle triangle. And a right angle triangle is base times height. So this one we would have to say is 2.9 height times 20, so percentage and percentage, divided by 2. And that would be the area of that triangle. The area of this triangle is going to be 8.6 times 20 divided by 2, but we have an area of a rectangle underneath it to worry about. So we'll say plus 2.9 times 20. And that will give us the area within this segment that is the second 20%. And we can continue to do this on and on such that we can find the area underneath the Lorenz curve, which is interesting to us and ultimately is going to be measurable by using the variable b. And the area above the Lorenz curve is given the variable a, such that the Gini coefficient is equal to a divided by a plus b. The Gini coefficient is simply a single number to help us understand what's happening in a Lorenz curve relationship. Well, okay, it's a number. Let's say it's a number. Let's say for this point that maybe, I don't think this is going to be accurate, but let's say the Gini coefficient is 0.24. Milo, is that good or is it bad?
That's relatively good.
How do you know that? Gosh, you see, I was afraid you would actually know. So how do you know that?
The lower the number, the more equal.
Okay, so if I was virtually on the axes, then A would be almost the same as A plus B, right?
Mm-hmm.
And my Gini coefficient would be nearly or perhaps even equal to 1 with some rounding issues. So a Gini coefficient of 1 is complete total abomination inequality. A Gini coefficient of virtually 0 is total equality. And the larger the Gini coefficient, the greater the level of inequality. But under the premise that some level of inequality is expected in a capitalist society and probably is productive given that our society is producers and workers at some integration, I'm hard put to immediately call this good or bad unless I have something to compare it to, right? Now, as it turns out, 24%, or 0.24, not great, not horrible. But it's just a number. It's kind of like, yeah, we can look at this curve. Yeah, that curve is underneath the line of equality. Could it be worse? Well, yeah, it could be way down here. Queen Catherine, right? Or it could be way up here, and it'd be better. So Lorenz curves and Gini coefficients are best utilized as comparative metrics, where maybe I'm comparing two different areas or elements. So I'm just going to give us the same relationships here for a second and suggest that maybe for female households or households where there's a single female that's the head of the household, maybe that is the Lorenz curve in the United States in 2017. Well, if that's the case, where relationally would we expect the Lorenz curve for households where we have, let's say, male head of household? Would it be above the Lorenz curve for female households or below? I'm figuring you're throwing something at me here pretty quick.
I'm just going to let you.
Well, I think without putting numbers to it, I think we would generally expect it to be above, right? Less unequal. And so now we've got one for Lorenz male. And so it's a comparative tool. Visually, and each one of these would beget a Gini coefficient style number, right? Such that the Gini coefficient A divided by A plus B for the female households would be a greater number than the Gini coefficient for the male households. So it's a good comparative tool. The Gini coefficient itself is an interesting tool because it lets us see in a number what otherwise takes, what, an eighth of a printed page, a quarter of a printed page, to represent with enough detail to be meaningful, right? Here we do it in a couple of digits. They're both instructive, and they both talk about each other, so we use them both. Maybe this is two populations in an economy at a point in time. Maybe it is Lorenz curve for working households in 2017 and in 1980. So maybe it's one population at two different points in time. Maybe it is Lorenz curve for the US and the Lorenz curve for Sweden, which is generally thought to be more egalitarian, more equal. Maybe you've got three different populations or three different points in time. It's comparative. I think when you start to see a Lorenz curve construction that's trying to have more than two or three moments in time or populations, you start to get a little bit condensed unless you're using the whole page, and it's hard to really see what you've got. I think you'll have an opportunity at some point to show me as much as two populations on a Lorenz curve and calculate their relative Gini coefficients. So that's the Lorenz curve, a little bit about the Gini coefficient. I want to talk about how we calculate Gini in a second.
Go ahead.
Is that where you wanted to go? Yeah, I don't want to leave this because there's some calculating things here. And I'll tell you the experience I had, and then I had an epiphany that I'm going to keep you from having to have. So when I first taught this course, I used the Ehrenberger and Smith text that Lindy has a copy of now. And if you go through that text, I don't believe that it gives you any shortcuts or any quick ways of calculating the Lorenz other than doing the whole thing. So let's use some of these numbers and let's look at how we would have to calculate the Lorenz or the Gini. So remember, A divided by A plus B. Also think about if this is 100% and this is 100%, what is the area underneath the line of equality? Well, 100% times 100%, or excuse me, divided by, no, 100% times 100%, 1 times 1 is 1, right? Divided by 2, A plus B, all always equals 0.50. There is no way around it. Because these are percentages adding up to 100 and 100. 1 times 1 divided by 2 is 0.5. Okay? And if I want to calculate the area above the Lorenz curve, which is A, right? That gets to be kind of complicated. I just showed you how this can be a segment, a series of triangles and rectangles. Even if we're down to the 1%, 2%, 3%, 4, or 0.5%, 1%, however you calculate this, it actually isn't a nice, perfectly smooth line. It may look like one if you have enough different points, but it actually is a line of lots of small, straight segments. Yeah, please.
On the final, would we be allowed to just express the integral?
Now, I'm sorry, say again?
For the final, would we be allowed to express the area under the curve just on the integral?
See, you guys that know calculus are a problem for this. Yes, if you have an equation that represents, a singular equation that represents this curve, and a singular one for this, we know that the integral or integrand will let us find the space between them. And if you have that, absolutely. I think it might be easier for you to do this, but you bet, because that's what we're talking about, right? But most of us don't like to pull out our calculus, and moreover, we don't necessarily have singular equations that help us with these. Okay? But that's exactly what we're dealing with. This is just a shortcut around using calculus. And it happens to be one that works, and that the textbooks will all use. Well, in this case, the Ehrenberg and Smith text takes us through a long calculation, and it is unnecessarily complicated and long. Let me kind of give it to you, and then I'm going to debunk, take it apart. I'm going to tell you that B, B is going to be the sum of some triangles plus the sum of some rectangles, right? If I can see B, I've got triangles and rectangles. If I can count those areas, calculate them, it's the sum of those, that's B. And I can rewrite my A plus B equals 0.5 equation, so I can say A is equal to 0.5 minus B. So all of a sudden I figured out how to calculate A without pulling out integration and integrands and integrals for calculus. Because I know that those are really just triangles and rectangles. I would tell you that in this class I would never hold you accountable to anything beyond quintile segregation, which means 5 equal parts for the economy. Now you might see 5 households, in which case it's easy to segregate them in 5 ways, right? You might see 10 households, in which case you got 2 households in each 20% segment. You might see 15, so you got 3 in each 20% segment. I wouldn't expect you to do decile integration, or I wouldn't expect you to do percentile, etc. integration. If you can do one, you can do all of them, right? It's just math. But recognizing these relationships, let's try to calculate the sum of the rectangles, or triangles, and then let's calculate the sum of the rectangles. Because we know that will give us B, and for B we can use our rule to get to A, and then we can do A divided by A plus B. Well, here, for our triangles, we have 20% times 2.9. So 0.2 times 0.029 divided by 2. And we got 0.2 times, what was the next one? 0.086 divided by 2. Plus 0.2 times 0.143 divided by 2, plus 0.2 times, what is it, 28.6, 0.286 divided by 2, plus our last one is 0.457 times 0.2 divided by 2, right? And that will give me the sum of the area of all those triangles. Base and height divided by 2 for each one. Well, some of us are comfortable enough with basic math and geometry and algebra to understand we can simplify this at a heartbeat and be happier as we do it. I can rewrite this and say, well, I've got 0.2 in the numerator, and it's common to all of them. and I've got 2 in the denominator, and it's common to all of them. So I can factor it out such that I have 0.2 divided by 2, and then just multiply that by 0.029 plus 0.086 plus 0.143 plus 0.286 plus 0.457. And I just made this a little bit easier, didn't I? And it is infinitely easier still. What is, without a calculator, 0.029 plus 0.086 plus 0.143 plus 0.286 plus 0.457? What's it equal?
1.
Wait a minute, what do you mean 1? How'd you come up with that? 0.29 plus 0.086 equals 1. Okay? So those buggers, Ehrenberg and Smith, never say this. The sum of the triangles in a quintile segregation is equal to 0.2 divided by 2 times 1, or 0.10. Quintile segregation, the sum of the triangles is always 0.10. Those lousy dogs, if they had only said such a thing. Now, if it was a decile segregation, 10 equal parts, it would be 0.1 divided by 2 times 1, so 0.05. So if it's decile, it's not going to be the same as in quintile, but it still is an easily identifiable constant. Because the sum of all of these is still going to have to be 1, because it all marches forward to end up at 100%. So that's easy. Equals, well, I'll just leave it up there, equals 0.1. Let's see if we can have some of the same kind of simplification with the sum of the rectangles. So the sum of my rectangles, how many rectangles do I have, by the way? I had 5 triangles.
4.
I know we have 4. This doesn't count. 1, 2, 3, 4. So I don't have as many values to think about anyway. And I still have my basic geometry. It's going to be base times height. Remember, the height's over here, right? So base times height. Base is always 0.2, so 0.2 times 0.029 plus 0.2 times, what is it, 0.1142 plus 0.2 times 0.2571 plus 0.2 times 5428. That gives me the sum of the rectangles. But I've got a simplification move here too, right? Because they all have 0.2 in common, I can factor that out. 0.2 times 0.029 plus 0.1142 plus 0.2571 plus 0.5428. And now I have the sum of my rectangles. Would somebody please add these up and multiply it by 0.2 to give us a number?
0.2.
Pardon?
0.2. Isn't it 0.2?
Yeah, so add all this up and multiply it by 0.2. By the way, this is the construction of what you will do in the review problem. These are not the numbers from the review problem.
It's too high.
You're right, but it's plug and play. It's awfully close. What,
0.11, or no, 0.188.
0.188. Okay. So now we can calculate the Gini coefficient. So B is going to equal 0.10 plus 0.188. Is it 0.188 or 0.1188?
0.18862.
Okay. So I'll put 6 there. So we've got 0.2886 is B. A is equal to B, 0.5 minus B, right? 0.5 minus 0.2886, which is, what will that be, Lindy? 0.5 minus 0.2886. Or Nate, if you got first, whoever.
0.2114.
0.2114. And A divided by A plus B, 0.2114 divided by 0.50 is what?
Is that 0.5?
Yeah, it's 0.5.
0.4228.
0.4228. And that is our Gini coefficient. Sometimes referred to as a percentage, but I don't think it's very accurately thought of as a percentage. Do we have a problem with one of the numbers? I'm seeing you kind of cock your head sideways.
Oh, never mind.
We're good? Okay. These simple rules in which the sum of the rectangles is the only thing that's not a constant for us and is equally or is easily calculable as 0.2 times the sum of the height of each of the rectangle legs, of which is only 4. And now you own the Gini coefficient. So what looks like a fairly complex string of equations, this plus something also, boils down to something really very simple. It's just a number. And the closer that number is to 0, the less unequal the distribution of income is in the society. The further it is from 0, and the closer it is to 1, the more unequal it is.
So would you consider this normal?
No, I would
Or
say
you
that
consider-
that's non-good.
That's pretty unequal.
That's pretty unequal.
So what's a normal number? What's the number you want that at?
I don't know what normal is. I'm not enough of an inequality or distribution of income economist to give you that. I will tell you that this is, if I remember correctly, and I state this in the video, so you may have to correct me, I haven't seen the number for a while. I think the Gini coefficient in the US is about 0.34, if I remember correctly, something like that. So this is bad. This is bad, okay. I think Sweden is like 0.2223-ish. We think of
And they're
Sweden.
the best.
And they're, amongst the OECD nations, they're certainly nearly the best, if not. Sweden, Norway tend to be some of the most equal. And interestingly enough, economically productive. Economically productive. Venezuela, for a period of time, was the most equal, but as it turns out, that may not have worked all that well for them. Okay? The cost of it was too great to bear. Because human beings and economies are what they are. So one of you might actually Google to see what these numbers are, but I think the U.S. is around 0.34, if I remember correctly, and I haven't looked at that number in a long time. Okay? Why is it such a problem for there to be terribly unequal distribution? I mean, Catherine, you're the queen. Is it? You're happy living in Northanger Abbey or whatever that, Downton Abbey, right? You like it there. Servants, you treat us well. We're your serfs. You're nice to us, aren't you?
Of course.
Yeah. Why is this an issue?
Probably limits the productivity of my country.
And at some point, the guy that drives your car is going to rise up in rebellion, and one of his cousins is going to kill one of your cousins, who happens to be king or queen or prince or princess of some other polity, right? Marx wasn't wrong when he talked about the problems that this can create. He just was a little too prescribed, and it was a little too simple. But let's face it, if there's 100 of us, and we're living in abject poverty, and then there's you're sleeping with one eye open, right? Because chances of your lifespan is not all that long. If we are hungry, tired, frustrated, put upon, and we're looking at our next generation of children having it at least as bad. you better be sleeping with one eye open, because you're done as soon as you close that eye, right? So that's where it's taken to an egregious point. I think that not quite as egregious as that is something that we either have or are approaching, and that is if we get to a society in which workers can't purchase the goods produced in the society because they don't have enough money to do so individually, then even the producers who own the firms will no longer have income, because if we can't buy your production, all of a sudden your productive capacity is worthless. So there's probably an Edgeworth box construction issue here where we can look at optimalities, Pareto optimality. I know I talk a little bit about Pareto optimality in the videos. Not a lot about it, but just as an illustrative point. Yeah, please, Mike.
So if sorry, I'm just trying
No,
to
you're good.
organize this in my head.
Sure.
So if all of the wealth goes to, you know, say the distribution gets even worse, where it's like 0.25% of the population has most everything. Wouldn't that create a scenario where those people couldn't possibly spend enough money to keep our economy going?
That is exactly the point that I was making a moment ago. It's just the other side of it. You're exactly right. So the rest of us don't have enough money to spend, so we're kind of impotent in terms of economic activity, and those very few that are left, they're not going to spend enough to support the economic needs of a 300 million or whatever number of person economy and society. You're exactly right. That's it taken too far. But if it's perfectly equal, then we know we have motivation problems, and we have a different kind of distribution problem, right? And you end up with, when you have perfect equality, then firms are not owned by producers, they're owned by us all. And that has shown that it just, for whatever reason, doesn't work very well. So both ends of the spectrum have trouble, and as shouldn't surprise you, somewhere in the middle tends to be productive and optimal. Probably not 0.4228, probably not 0.34, but somewhere closer to 0.2-ish somewhere, maybe. Don't quote me on the number, but it's better.
Fred says that the Gini index for the United States is, as of 2016, 41.5.
Okay, so it was very close to that number. Okay. So this, thank you, bless you. Can you see what Fred says, or just Google what they say about Sweden or Norway?
Mm-hmm.
So, Google Gini Norway, or Sweden, Gini Sweden. What other questions while she does that? Okay. So, just remember how to set it up, remember how to calculate it. My guess is you'll have an opportunity to do so.
Excuse me, I have a question.
Please, Kathy.
So I know part of the argument for like keeping lower taxes for the wealthy business owners is that they won't move their businesses to other countries that have lower taxes, kind of thing, so that like they'll stay in America, kind of thing. So like, how does that work?
That's a really good question, excuse me. So separate businesses and business owners, okay? So we've gone through a round of tax reduction for businesses such that the federal business or corporate tax bracket now is 21%. And the average state tax bracket for business is about 5%, so we're at like 26% or so corporate tax, whereas we've come off of that most recently being like 34%. So that's a big change. That 8 points is non-trivial, right? But that doesn't talk about income inequality in households. That's the business's tax bracket. So those businesses are owned by households and individuals at some point, even if they're owned by mutual funds, pension funds, etc. At the end of the day, it's going to filter down to households and individuals. And the profits in those businesses then become taxable income for those households and individuals. And so maybe the tax structure for wealthier individuals is problematic. I don't want to get too much into macroeconomics, but there's a concept referred to as the marginal propensity to consume, or its corollary, the marginal propensity to spend. So if I've got $1 million annual income, spendable income, and you give me an extra $1,000, am I likely to go out and spend it? I'm probably already making more than I am spending, because at $1 million, I probably should be able to save some of that. So you give me an extra $1,000, what's my likelihood of spending it? But if I have $1,000 of annual income, and you give me an extra $1,000, what's my propensity to spend it? Absolute, right? Because my unmet needs are probably acute, okay? So there's this marginal propensity to spend, and it is spending, ultimately, spending and investment that are going to drive economic growth. Depends on whether you think we're demand-led or investment-led. And prior to somewhere in the 1980s, we were an investment-led economy. There's some pretty good evidence that we've become demand-led. So growth for us happens because of consumer demand today, more so than it does for investment. Where it's not always been that way, and it's arguable. I think if you were to go into the Trump White House, they would argue that we're investment-led. If you go into the halls of many universities or think tanks, including the Federal Reserve, they're going to argue that we're demand-led. And every year the evidence becomes clearer and clearer that we're demand-led. But that marginal propensity to consume issue is a big deal. So yeah, give me more money. Let me be wealthy, give me more wealth. I'm probably got it available to invest, but I'm not spending it. And just investing it when no one's spending money isn't going to drive anything, right? So that's the problem. What did we say about Sweden?
29.2.
Okay, so a lot less than, but not the 0.2 range I was thinking. Okay, so